Okay, good morning, Muranda. Respected today's chief guest and keynote speaker.
Sir, your voice is mute. Sir, we are unable to hear you. Your voice is mute.
Good morning to one and all present for today's session. On behalf of the institution of Institution of Engineers, Salem Local Center, it gives me immense pleasure to welcome you all to today's special lecture on the celebration of World Telecommunication and Information Society Day 2025, being held in association with Sengundar Engineering College, Trichangood. Actually, this year is especially significant for us as we mark the 30th anniversary of IEI Salem Local Center. Over the past 3 decades, our center has consistently worked to promote engineering excellence and professional development across the Salem region, building a strong community of engineers dedicated to the progress of the society. As many of you know, World Telecommunication and Information Society Day is observed every year on May 17th to raise awareness about the possibilities that use of the internet and other information and communication technologies can bring to society and economics. It also aims to promote way to bridge the digital divide. The day marks the founding of the International Telecommunication Union (ITU) in 1865. The theme of the year is gender equality in digital transformation is both timely and crucial. Despite significant progress in digital access, gender disparities remain a challenge in many parts of the world. Empowering women and ensuring equitable digital opportunities is essential for sustainable development in inclusive innovation. Let us also take a moment to introduce our organization. The Institution of Engineers India is the largest multidisciplinary professional body of engineers in India, established in 1920. With a legacy of over a century, IEI continues to contribute to the advancement of engineering and technology in the country. The Salem Local Center, since its inception in 1994, has actively engaged in organizing technical seminars, workshops, guest lectures, and community development programs, aligning with the IEA's mission to foster innovation and professional growth among engineers. We are deeply honored to have with us today Dr. Nanipriya Singh Ma'am, Assistant Professor in the Department of ECE, National Institute of Technology, Kurukshetra, as our chief guest and keynote speaker. We are eagerly look forward to hear insights on this important subject, ma'am, on wearable technologies. I also extend my heartfelt thanks to our partner, Sengundar Engineering College, for their collaboration in organizing this meaningful event with their support. I also welcome all the participants joining us virtually from various parts of the Salem region. Your presence enriches this gathering. I encourage you to actively engage in the session and make the most of this opportunity. With that, let me once again warmly welcome you all and wish you all fruitful and enriching session ahead. Thank you. Now I hand over the session to Dr. Aarti ma'am.
Thank you so much, sir. So, Honorable Chairman of IEA Salem Local Center, Dr. K. Tangraj, sir. Honorable Secretary of IEA Salem Local Center, Dr. C. Davamani, ma'am. distinguished chief guest, Dr. Jnanapriya ma'am, respected committee members, dear colleagues, and my dear students. A very good morning to all. Today, 17th May 2025, we gather to celebrate the World Telecommunication and Information Society Day 2025 to recognize the transformative power of digital technologies and their role in shaping a more connected, inclusive, and sustainable future. This year's theme, Gender Equality in Digital Transformation. The Sustainable Digital Transformation is one of the Union's strategic goals approved by the ITU Conference 2022 to foster equitable and inclusive use of telecommunications, information and communication technologies to empower people and societies for sustainable development. The world is moving slowly towards gender parity in internet use. Based on the ITU Facts and Figures 2024 report, an estimated 70% of men use the internet worldwide in 2024, compared with the 65% of women. Although there are 189 million more men than women using the internet, the world has been moving towards gender parity, except in least developed countries. Gender geographic and economic divides prevent equitable access to the internet. Equal for women and girls in the ICT sector remains an ongoing challenge of extending the benefits of new technologies to all the world's inhabitants, regardless of age, gender, ability, or location. In 2025, the 30th anniversary of Beijing Platform for Action offers a chance to accelerate action for gender equality in digital transformation. The Beijing Plus 30 action agenda includes key actions to advance gender equality, such as bridging the digital gender gap. It focuses on 6 key actions to ensure all women and girls benefit from a digital revolution, are free from poverty and violence, enjoy full and equal decision-making power, live in peace and security. This day marks the founding of the International Telecommunication Union, the United Nations Agency for Digital Technologies. This yearly celebration helps raise awareness of the possibilities that the use of the internet and other information and communication technologies can bring to the societies and economies. Thank you so much for the wonderful opportunity. So now may we invite Ms. S. Bhuvana Madam, HOD of English, to introduce the chief guest.
Thank you, ma'am. A warm welcome to one and all gathered here. Ma'am, is my voice is audible to you?
Yes, ma'am, audible, ma'am.
Okay,
yes, ma'am.
Thank you. Thank you. I'm really very delighted to introduce our chief guest, a renowned expert in signal processing and a passionate academician whose work bridges innovation and impact. Yes, our chief guest, Dr. Jnanapriya Singh, is currently working as an assistant professor in grade 1 level in the Department of Electronics and Communication Engineering at the National Institute of Technology, NIT, Kurukshetra, since November 2022. Prior to this, she dedicated herself nearly a decade of service as an assistant professor at NIT Uttarakhand from July 2013 to November 2022. She holds her PhD in signal processing from IIT Delhi and completed her MTech in signal processing from Netaji Subhas Institute of Technology, University of Delhi. During her doctoral research, she collaborated with ST Microelectronics, Santa Clara, California, USA, and work was showcased at CES, the world's largest consumer electronics show, a rare achievement that speaks volumes about her global research and technical prowess. She is the innovator of 5 granted US patents and 1 European patent. She is actively involved in research projects funded by prestigious agencies such as the Ministry of Electronics and Information Technology and the Department of Science and Technology, DST, Government of India. Her primary research interests include contest awareness, image processing, speech and biomedical signal processing for IoT and applied machine learning, etc. Our distinguished chief guest has made significant contributions to both sponsored and collaborative research projects. She is the principal investigator for a DST funded project on an IoT based real time farm monitoring system and has served as a co investigator in the SMDP C2SG project funded by MITI. Her collaborative work with ST Microelectronics led to the development of probabilistic frameworks and signal processing algorithms for modern devices. She has also worked on deep learning applications for rehabilitation in collaboration with institutions in Uttarakhand. With over 10 journal publications and 13 conference papers, her work reflects both depth and diversity from Indian Sign Language recognition and great analysis to multi-modal stress detection and structural damage monitoring. Our chief guest is not one of personal accomplishment, but of creating knowledge, empowering innovation, and mentoring minds. She is a shining example of how science and dedication, when intertwined, can change lives. Due to time constraints, I have merely skimmed the surface of the chief guest's exceptional contributions because, ma'am, your profile prolongs as it has no end. Ma'am, we are truly honored to have you with us today, ma'am. Now it's time to roll the session, ma'am. Over to the chief guest, ma'am, Dr. Jnana Priya Singh.
Thank you so much for your kind introduction. Now I would like to start the presentation. I'm sharing. Is my screen visible?
Yes, ma'am.
Yes,
Visible,
ma'am.
ma'am.
Okay. A very good morning to all my dear colleagues. I welcome you all today for this World Telecommunication and Information Society Day 2025. And thank you so much for inviting me over for this particular day. Today, I would be talking about gender equality in digital transformation with special emphasis on stress recognition using wearable technology. So basically, I would be first talking about the gender equality theme, which is required in digital space. And then I would be talking about wearable technology with a specific application towards stress recognition. So first, before starting, I would like to thank the Institution of Engineers India, Salem Local Center, for inviting me today. And thank you also to Sengutar Engineering College for associating with IEI. So basically today first I'll talk about the introduction for gender equality. The first and foremost question when we are asking on this particular theme, we are thinking, why does it matter? Why are we even talking about it? Why are we spending time on things like gender equality? So the foremost important part is that with inclusive innovation, there would be sustainable development. We have few sustainable goals that are to be required to be achieved, and those sustainable goals could only be achieved when there is equality in every respect, which also includes gender equality. Now, the current status is that women represent only 50%. Women represent 50% of the population. Yet, the digital access, participation, and representation remains unequal. And when we are talking about field, especially of STEM, science and technology fields, Then this STEM field, particularly with emerging technology, AI, IoT, cybersecurity, etc., there is still a very big gender gap in this. So the current status, the current statistics does not is not supporting a sustainable development, and with this comes the barriers. The barriers which we are talking about is in every field, which includes technological field, educational field, as well as your cultural and society. So when we are talking towards technological barriers, we are talking about lack of access to affordable devices and internet. There is gender biasness in hardware and software, which is inculcated. Whenever we model the designs, whenever we model, there is a specific, the software inherently learns on whatever model, whatever data we are providing. And if the data is not correctly biased towards every, means if it is biased towards a particular gender, then the model is learned wrong. So we have to be very specific. We have to be very alert about these things. Apart from that, there is lower participation of girls in STEM education. There is digital literacy gaps. So all these points are still lacking in STEM education. We are still restricting on the basis of gender. So why are these things happening? These things are happening basically because of a cultural divide which has been created and which is still instilled in our minds. So we are still not very open to talking and discussing various points related to gender inequality. So, with today's session, we would like to discuss how to overcome this. What are the things that we as an engineer we can do? What are the things which we can focus upon in our research that would help us to create a more sustainable developed country? So let us talk about what things can help us. The things which can help us are policy initiatives, and which the policy makers are very much enthusiastic about. So the policies like National Digital Literacy Mission India, this is still taking into account that trying to lessen the divide between the both the genders and make technology accessible for everyone. Again, there are UN Women's Program, which is equality in technology. They are also striving towards limiting the gender biasness. Apart from this, we can also help in grassroots levels. The topmost level policymakers do make policies, but it will come down only when the grassroots empowerment is there. And how can it help? This can be helped using women-led innovation hubs, which there would be encouragement towards lesser gender divide. There could be skill development in rural areas using mobile-based platforms. So these things can help us in grassroots empowerment. So what are we call the call out to action is, let us transform digitally and equitably. We should promote gender responsive innovation. We should ensure equal access, skills, and opportunities to both the genders, irrespective of gender. There should be opportunities for everyone. We should build inclusive ecosystems. Everything, the ecosystem from classroom to boardroom, these from top to bottom, everywhere there should be an equality. And what we are thinking about is empowering one and all, irrespective of any gender. So these are the call out for actions which are required in today's world for having a gender equality in digital transformation. So basically on this particular theme, I would like to move a step ahead and talk a little bit more about technology. How can we help in having a more sustainable development? And with this, I would like to today talk about gender equality in digital transformation with special emphasis on stress recognition using wearable technology. Now, whenever a person is having stress, it does not venture into whether the person is of which gender. The stress is equal among both the genders. Now, when we are working towards stress recognition, what are the technologies that could be used? A camera could be installed which could check out what are the facial emotions which are taking place, but that is not feasible because whenever you are taking into account a camera, you are confined to a closed space where a camera is always watching upon you, and this in sort of takes intrusion into your privacy space. So we don't like that. How can we overcome it? We can overcome it by using wearable technology. This will not have an impact on our privacy, irrespective of what gender are we talking about. Even if we are talking about if a female is there and she is not comfortable of being imaged or photographed all the time, the camera technology will help can help to use recognize the stress, but it will make her uncomfortable. So the wearable technology like smartwatches, talk more about wearable technology, but that can be used for recognizing the stress. So once I'm starting over, first I'll talk about a little bit about wearable device, and then I'll talk about what exactly uh, is our team working upon. So basically, when I say wearable device, wearable means whatever a subject or a user can wear, whether it is a sweater, belt, clothes, it is everything. So this wearable device is an over it needs to be worn, and it should not be something which is not accessible, or it is very heavy. It should not be heavy. So this concept of wearability is particularly important in fields like monitoring of healthcare, well-being, fitness, sport. So there is wide application for wearable devices. So let me talk about the differences between conventional device and wearable smart devices. So if you talk about a particular desktop or a laptop, these all things, or a smartwatch, or even a smartphone, these devices you need to carry. You're not wearing it. You have to particularly carry around the laptop. It is not feasible to carry 24/7. No, it is not possible. But what about if you have a wearable cloth? So there is a particular um, team working at IIT Delhi on these wearable technology for textiles. The textile department is actually working upon integrating electronics onto clothes. So this is something which is truly wearable. A person is putting on clothes and he won't even have the pinch of that he's carrying out on a particular device, or having a patch on your skin. It is very easily removable tattoo type of thing, which can be used, which can help you to check your health parameters, and also not a burden to carry around. So whenever we are talking about conventional electronics, very often wearable technology is based on conventional electronics, whether it is rigid or bendable, but it has few features like lesser weight, lesser power consumption, low area. So these all things help us to make technology more accessible. So let us talk about wearable technology. It is more disruptive and very easily can be used in day-to-day life. So, but whenever we have, so for example, today we are talking about telecommunication day. There is a particular body which is governing all these things. Telecommunication day, telecommunication, ITU society. So apart from that, there is also an ICO, IEC. This particular body has made few terms which are particularly, it needs to be compatible with each other. So what is these all terms are basically what is a wearer, wearable technology, how are the things communicating with each other. So I will not go much into this particular terminology for MPJ wearables, but yes, let us talk a little bit about IEC SG10 topic. So basically what we are talking about wearable smart devices. Instead of wearing, you can also have near body electronics, which can have a communication with all the sensors, can communicate with the sensors on the body, and you can have a body area network sort of thing, or you can have on body electronics device, or you can even have in body electronic devices. So these are the innovative technological trends which we are talking about, which will soon be in market and will be a part of our lives. When you think about smartwatch, the smartwatch was developed in lab way back, even a decade before. But there were few power constraints, which was limiting the smartwatch to be rolled out in commercial market. But as soon as those bottlenecks were resolved, those things were a super hit in market. Similarly, there are a few technological trends which you'll be seeing soon. So let us talk about what do I mean by on-body electronics. So basically, I'm talking about electronics which is fitted at any part of the body, or any you can have it on like a smartwatch. You can embed an electronics in your shoes. You can have those kind of applications which would be curated for a particular, if you have a problem statement, and you can curate your wearable technology to solve those problems. So the word on body electronics means that you have sensors or an edge or fog computing on the body itself. When we talk about in-body electronics, there are a few, this area is more in advanced, this is in lab, but we can expect that within a decade, this will be the norm of society. Just like within few years, smartwatch is a norm of society. It is very freely, very cheaply available with good power. Uh, the power consumption, your smartwatch will remain active for at least 1 week or so. So these are the things which are in market now. But the future lies in a step ahead. What if you can have a chip which is inserted in your ear, and instead of having an outside hearing aid, you can have a chip inserted and you can hear it by all your own self? What if you can develop its electronics which you can gulp it down your stomach, and it will capture all the sort of problems which is being created. An ulcer is creating a problem, it will go through your whole system and it will capture all the information and then transmit it back to you. So these in-body electronics are also um, getting in improving day by day, and we shall be seeing it soon. Apart from that, we have smart textiles. So I was telling you about this, that at IT Delhi, there is a particular lab which is working about this smart textiles. You have two set of clothes which are smart, and those smart textile, those electronics which are embedded on to the fabric, it will send all sort of your health functionalities, your heart rate, your breathing rate, your muscle fatigue, everything, and it will be transmitted onto a cloud via your mobile app. So these all things are taking place and it is in progress. So with this, when I am talking about these technological trends, so basically we are very much comfortable with smartwatch, smart ring, we have these in market. We are even looking at other items which can be easily integrated. So there are smart shoes available as well. Nike and Adidas, they have their shoes for professionals, for sports person to measure what are the particular places which are emphasizing on particular things. So there could be smart glass, smart mouth guards, smart clothes, smart strips. So everything, there are every particular wearable technology is expanding from what we know as only a smartwatch. It is going to other items as well. So when we are talking about technological trend, if you just think about, in earlier times we had very rigid electronics. We were having desktops, then we had portable laptops. So you in your own lifetime, so in your childhood, seen desktops, then you saw laptop, then you saw mobile phones which are as smart as your laptop. Then you are today we are having smart watches. So what is it? We have gone from rigid devices to wearable device, and from wearable device we are going towards wearable device which is flexible. What which is flexible? For example, e-textile, smart clothes that we are talking about. Then we are planning towards attachable devices. You have an e-tattoo, you put it on your arm, you capture all the information that is required, and you transmit it to a nearby computing device like your smartwatch or smart tablet, something of that sort. And it will transmit all your information onto the server, and then it will get back to you again. Then after that you have implantable devices which can be implanted under the skin or just under the skin, very exothermal. And then you can have ingestible devices. So the technology is going more and more inclusive. Instead of having a computer or technology outside and distinct of the body, we are moving towards more inclusive and more integrated technology. So this is the technological trend. Now you can think about what is the research application which you can work in your area, and how can you modify towards these particular things. We can even think about what are the protocols that would be helping us for low power consumption and to transmit the data from these sensors to the nearby mobile or smart devices. What else? How the power consumption could be minimized, how the area could be minimized, how we can have this technological adapted to a wide area or wide population. How can it be marketed to be socially accepted? So these are the things for you to ponder upon. You can think about it, you can get back to me. So let us go ahead. Now, we can focus on healthcare also, but as I am more focused towards stress recognition, we'll work upon more upon that. So basically, you have wide variety of biomedical sensors, but are all those biomedical sensors uh, wearable? The answer is no. We have very less number of sensors which are portable. One of the most important feature of wearable technology is that it needs to be portable. It needs to be very light in weight, very low power consuming, and most the biomedical sensors may or may not have those particular features. So when you're talking about wearable biomedical sensors, you can think about how to optimize those features as well. Now, when we are talking about conceptual model, what is the model that we are thinking about? We are thinking about that there will be some wearable device which will be having sensors. It will take the data from the environment. That data which has been taken from the environment will be given. The data will be output to the processing unit. That processing unit could be a smartwatch. It could act as an hub for fog computing. It can compute at a small stage at your phone itself, and then you can um, give it on to the cloud to save the information. And after that, you can provide that data, the curated data, to the users. Now, just tell me, is it possible that if you have a sensor which is suppose normal person, not a technology person. A person is of arts and the person is having a smartwatch. Will the normal person not having an engineering background will be able to appreciate that the person is having 150 plus BP? No, the person will not be able to appreciate the values. He will be able to appreciate the warnings that yes, after you have obtained the raw data, you have done processing upon it, and then you curate the data to be given to a normal average person to make him understand. So those data needs to be processed and then given to the user. And then the user can then again work upon improving. For example, the BP is high, he can take few medicines or lie down, make himself calm, so that interaction can again. So this is the conceptual model which we are talking about for any application you want to work upon. This particular model will help you to have an application which could be designed, and once you have designed it, you can even publish it, you can even patent it. So earlier I was talking about body area network. Basically, I was talking about that you have sensors, and those sensors are placed at various parts of the body or near to the body, and those all sensors are talking with each other, and then they are communicating to the hub. So these edge devices would be, these local devices, local sensors would be connected to a particular central node processing unit. And then you can talk about those things. So you can have a health app upon it. You can have a telemonitoring system. You can monitor all those things, all the parameters of the biomedical on your mobile phone, and then you can now, as a telecommunication person, you can also appreciate what sort of technologies, what all sort of links that can be used. Now, if I say I'm going to use Bluetooth, the Bluetooth will require more power. So your answer will be, okay, let us use Bluetooth but low energy. Then I will say that, is there any more option which will require lesser power input? You try to optimize in every sense so that it could be used by the masses. It could be used by an average population. So the technologies, the protocols for communicating could be a good work for uh, for helping us reduce the power consumption. Then once we have obtained the information to your smartwatch or to a processing unit, a central hub, you can even transmit it to the cloud. Now that, what sort of technologies could be used over there, whether it is Wi-Fi, whether it is 4G, 5G, all those things you can work upon as a communication person. So once we have talked a lot about digital healthcare ecosystem, let us talk a little bit about what are the applications which are available at currently in the papers. So when I'm talking about mHealth, what are the functions that are available, whether it is remote physiological monitoring or whether it is a remote consultation with there is contact tracing technology. So there are various functions with various communication mode. You can check upon this particular papers from DING IEEE Reviews in Biomedical Engineering 2020 paper, and this is a very good paper. You can think about going through the paper if you are actually thinking about working in this particular area. Now, I'll escape a little bit and let us talk about stress recognition. How is my team working in affect recognition, or in other words, stress recognition? How the team is working and how is it utilizing the wearable technology to identify the stress in a person. So basically, whenever we are talking about a particular statement, if I'm talking about this affective state recognition, the first and foremost question comes is, what do I mean by effective state? So a state with that describes the internal state of a person. When I use the word stress, this stress is actually a negative word and it is in contrast with amusement. So actual word, this is a local lingo. When I say the word stress recognition, this is a local lingo that you want to say that what is the stress? But the actual word for it, the technological word for it is affect recognition. What do you want to understand? You want to understand what is the internal state of the person. The person may be saying that the person is fine, but is it actually the case? How will you identify it? So the problem statement is recognition of the affective state, and the affective state are subjective experience, emotional feelings that are difficult to be described but have been linked to bodily states, such as these are the external stimuli. What are the external stimuli that we are talking about? We are talking about audio, we are talking about visual, touch, smell. So, for example, take an example. Today morning, you woke up, you have a full day duty, and by default, your child feels sick. Now, irrespective, you have all the workload upon you. You have responsibility of going to the office, and you have home responsibilities as well. What are the sensory inputs that gave you those information? You saw with your eyes. That is, audio information was there. There was visual information. There was smell. So all these input goes in your brain, and it provides a response. So the team was working upon three basic different response, which was baseline, stress, and amusement. These were the three classes, and the we were trying to understand how to identify the affective state. So basically what happens, like I have already discussed, that we have an input stimuli. It through those stimuli it goes in our goes to our brain, and there is hypothalamus, which is the central control center of the brain, and it hypothalamus is responsible for activating sympathetic nervous system and causing physiological changes. It releases stress hormones, which directly goes to the blood. So due to these things, what are the physiological changes that we are going to see? We will see changes in the neural system, we will see changes in the skin tissue, skeletal muscles, respiratory system, and cardiovascular system. So how are you going to check what is the difference in the neurological system? How are you going to check what is the difference in the skin tissue? These all things are going to be checked by the sensor. Now, where is the sensor placed? The placement of the sensor is important because if you talk about heartbeat, if I say if a person is stressed, the heartbeat is not normal. This is the figure which we have taken. The upper one is the heartbeat. When a person is stressed, the heartbeat becomes abnormal. Otherwise, you see a cyclic change. So these sensors, what I'm talking about is, you have a set of sensors which you take, which take the data from our body. What are the sensors that we are talking about? The sensors that we are particularly talking about is EDA, temperature, accelerometer, ENT, respiration, ECG, and EEG. So these all particular sensors, they take into account, they give us raw data. That raw data is not helpful for any layman. So to give the information to the user, you will have to model we will need a deep learning algorithm from it. So if you have a little bit of idea, you'll appreciate that whenever you have a signal, you will try to have preprocessing on it. Then you will try to model you can have any sort of machine learning algorithm. I'll not say that only deep learning is correct, but it depends on what sort of data are you taking for your application. So for my application, we had number of sensors. We had EDA, ECG, temperature. We have 5 modalities of sensors, and using those sensors, the data was quite extensive. We tried to use hybrid deep learning model. We tried to extract the features using convolutional neural network. And once the feature was extracted, we tried to understand the temporal information. We tried to understand that what was the effect before and how is that time effect. Temporal means time. So we were trying to extract the temporal information using LSTM, and then we wanted to give emphasis on particular factors. So there was an attention vector, and then we had an output in the terms of probability. So these probability were in the sense of probability. What is the probability that a person is stressed, or what is the probability the person is amused? What is the probability the person is in baseline neutral structure? So this work is already published. That is why I've given the reference. So basically, the placement was at these particular places because this was pioneer basic work. So the placement was on the chest. We can adapt it to hands also. We tried to model, and then after modeling, we had after training, we tried to understand and hyper-tune the parameters to obtain a high accuracy. We also tried for comparative performance. What if we take only ECG? By taking only ECG, we understood that even after trying various models, after taking CNN model, after taking CNN LSTM model, even after providing attention to the model, we were only able to obtain 74% accuracy. Then we tried with only EDA, we tried with only EMG, we tried with only respiratory, we tried with only temperature. The response was not very encouraging. So with this, we understood that taking only one sensor will not help us. We have to go multimodal. And by multimodal, by multiple sensors, we tried various combination of sensors to understand which particular combination will give us more accuracy. Now try to understand why did we try for single modularity. We were trying to optimize the power consumption. As you increase the number of sensors, the power consumption also increases. So we were trying to optimize in every respect. We were trying to decrease the number of sensors as well as try to increase the accuracy. So with this, we tried to have a balanced structure. So there was various type of fusions also we tried. We tried to obtain the answer. So finally, we obtained a 92% accuracy with our proposed model because we were having temporal as well as feature extracted by CNN. And with this accuracy, we obtained whether the person is neutral, whether the person is stressed, or whether he is amused. So these were the 3 classes we tried to understand. So with this, I would like to end today's session, and I would request for a free interaction with everyone. Thank you. I'm open for questions.
Artigam, shall I proceed?
Yes, ma'am. Yes, please.
Is there any doubt? You can clarify your doubts, my dear participants. Or otherwise, we will go for the next step. Thank you so much, ma'am, for your crystal clear explanation. I hope this will help us to know about the current systems and techniques. Now I would like to welcome Dr. C. Davamani, Honorary Secretary, IEI SLC, Salem, to propose vote of thanks.
Thank you, ma'am. I am audible.
Yes, ma'am, you are audible.
Okay, thank you. Most respected our chief guest and the keynote speaker, Dr. Jnanapriya Singh, madam, our beloved chairman, sir, Dr. K. Tangaraj, respected principal, sir, Dr. R. Satish Kumar, sir, coordinator, Dr. Aarti, madam, professor, deans, faculty members, my dear students, of Sengundar Engineering College and Mr. Thiago Salem Local Center office staff. Good morning to all. It's truly an honor for me to extend the vote of thanks in this great occasion of special lecture with the celebration of World Communication and Information Society Day 2025 in association with the Sengundar Engineering College in the theme of gender equity in digital transformations. On behalf of IEI Salem Local Center, my heartfelt gratitude to our chief guest and keynote speaker, Dr. Jnanapriya Singh Madam, Assistant Professor, Grade 1, Department of EC, National Institute of Technology, Kurukshetra, for sharing her valuable insights, perspectives, and real-world experience. Thank you, Madam, for shed the light on the digital gender device. Also inspired us with practical strategies and pathway to make technology more inclusive and empowering for all. My sincere thanks to our beloved chairman, sir, Dr. K. Tangaraj, for valuable presence and grace this occasion with a warm welcome. Thank you very much, sir. I extend my sincere thanks to our principal, sir, Dr. R. Satish Kumar, for his continuous guidance and support for our IE Salem Local Center always, and always are his focus on the transferring latest technology to students community. Thank you, sir. It's my privilege to thank Dr. R3 Madam for her engagement and wonderful support to organize this event in successful manner. And also I have to thank Satya Madam for her wonderful MOC. I record my sincere thanks to Mr. Thiago for his ensuring everything is run smoothly. I'm also thank our participants and participants of the students and the professors, all the faculty members. Your active involvement and presence have added immense value to this seminar. Your commitment to promoting the equity in digital space is what keeps this conversation alive and growing. Thank you, one and all. Once again, thank you very much for each and everyone present here. Thank you.
Thank you so much, ma'am.
Thank you, madam. Thank you so much. Thank you, madam. Thank you, sir. Thank you, Captain, sir. Thank you, principal, sir. Aarti, madam.
Aarti, ma'am, thank you.
Satya, madam.
Thank you.
Thank you, ma'am. Thank you, ma'am.
Thank you.
Thank you.